Hey, welcome everyone.
Welcome, everybody, to another great installment of the Learn Live session. Learn Live, where we take the great content that we have on Microsoft Learn and mix it with a live audience so we can learn together. I'm not sure if that's the official Learn Live slogan, but I just made that up, so that's what we're going to go with. And today we're going to look at working with generative AI models with the Azure AI Studio. My name is Corey Stegered Pace. Coming from Stockholm, we have great internet in Stockholm, but I'm been informed that my video is kind of laggy, so I want to apologize ahead of time. It's not you, it's me in this case. But I'm joined by Mary Jo. Hello, how are you, Mary Jo?
I'm great. Thanks, Corey. Yeah, I'm Mary Jo. I'm a senior content developer and I'm actually based in Amsterdam, so we're pretty close together.
Close together but far apart. But that's what the beauty of live audience and streaming. We can all be coming together globally. And I would love to see in the chat where everyone's joining from. We have probably a global audience, so also be respectful of that. But let's get into it now. If you go to the next slide there. So you might join this video randomly. Maybe you joined just one session. Maybe you were searching on YouTube for generative AI models, and somehow this has been recommended to you immediately. But this is actually sitting in a whole series of videos and actually a skills challenge, what we call at Microsoft, where you are able to go through a series of modules, compete against each other, and also be rewarded. So in this case, we have the AI skills challenge going on until the 19th of April. And you have both the series that are going almost daily, I think now, as well as on that link there, we have 4 tracks, which is using Microsoft Fabric, Azure OpenAI, Azure ML, and the Azure AI fundamentals. So feel free to choose one, choose all of them. I don't know if that's possible, but it's a great way to learn together, and get this nice bundle of information and content. And speaking of content, what's coming up on the schedule for us? So today we have, like I said, the working with generative AI models in Azure AI Studio. But right after us tomorrow, we even have a get started with prompt flow to develop LLM applications, and you can see the rest of here. So we have a jam pack, I guess a week and a half, something like that, coming up for you throughout this entire skills challenge. So you can watch us, you can do the skills challenge, you can really up your game in terms of generative AI. And although Mary Jo and I have the pleasure of being the faces of this learn, so we actually have someone in the background, but should be called out for their amazing work. Shivam, he'll be the moderator. So I believe he's in the chat now. You can say hello to me, Shivam. I can see in the chat. Hello, Shivam. He'll be able to answer most of your questions. We'll try to take some questions at the end if we have time. Sometimes we don't, but Shivam will be there to help out with all of that if you have some pressing questions you'd like to ask during the presentation. And you're in luck because today you get a 2-for-1 deal. And I don't just mean because it's me and Mary Jo here, but we're actually going to cover 2 Learn modules. One talking about understanding the transformer architecture, and the other one talking about fine tuning. And sources tell me that we not only have me, a guy who just likes to click buttons and find out what's going on, but we have Mary Jo, who sources tell me you actually made these modules. So I want to ask you a question. When you made these, did you think one day you'll be here presenting with me, specifically me, on these modules?
No, never in a million years did I think I would be that lucky.
Oh, wow. What an honor. What an honor. Okay.
Yeah.
So this is a good start. So Mary Jo, why don't you take us away there, take us to get started here on the actual content behind these modules. And like you said, this is a learn live. So feel free to watch this. Then you can go to the modules yourself to complete them. But this will be a good guidance. And we'll actually have some additional nuggets of knowledge, as I like to call them, throughout this entire workshop.
Yeah, perfect. Thank you, Corey. So like Corey already said, we're going to cover 2 modules that are both live on Learn, so you can go through it yourself in any pace. And because it's already on Learn as well, I want to make sure that we really call out specific things or give a little bit more context so that you understand why the modules have been written a certain way or what you could think about when you're going through them. But I would say generally the learning objectives really is to understand large language models. Specifically, the first module that we also linked to in the previous slide is about, I would almost say, like the history of natural language processing and what has led us to be where we are today. And then we kind of go into Azure and understand how we can work with these language models within Azure, how we can explore foundation models, what are they, how can you choose one, how can you fine-tune one, and finally also how you can evaluate and deploy a fine-tuned model. There are exercises for both of those modules. We'll be demoing those exercises. And just to note, though the modules have been written for Azure Machine Learning, we're actually going to focus in this session on Azure AI Studio. Just so that you know, Azure Machine Learning Studio and Azure AI Studio are very similar. They're actually built on the same technology. But for awareness, Azure Machine Learning Studio is more for those that have also, like, they also want to take that opportunity to train their own models and to manage your own models and deploy your own models, and additionally also work with language models. Whereas the Azure AI Studio focuses a bit more on, I would say, a lot of pre-trained models and really making those ready to be integrated in applications. But again, like the underlying technology is the same. So a lot of the concepts will be similar across both studios, but sometimes the UI is just a little bit different.
That was a great way to explain the differences between ML Studio and AI Studio. As you know, Microsoft here, we love our studios, so it's always great to hear how to distinguish from them, for sure. And yeah, good point, right? So you'll see screenshots in the Learn module of the ML Studio, but you'll also see what it looks like here in Azure AI Studio for this session.
Yeah. So you get the best of both worlds, really. So you see both of them.
Wow. Yeah, this workshop's getting better and better.
Yeah,
The
right?
value here.
I think also because I think Azure AI Studio is still in preview, so not everyone will have access to it. That's also why we wrote the content for the ML Studio. But so for some people, it might be like a glimpse into the future when it goes generally available.
Nice.
Yeah. Awesome. Well, okay, so let's start a bit with the theory. I'm sorry, we're going to start with a very dry presentation, hopefully not too dry, but it's really just to make sure that we kind of understand the underlying concepts before we dive in and work with the models themselves, although that would, of course, be the most fun part. So I'm going to cover the concepts mostly to kind of pinpoint why it is important to know about them. But again, like the modules are there. So if you want to read through it at your own pace, you could do that after the session. I just want to kind of go through the concepts and highlight why they're important to understand what we're working with. Ultimately, of course, we're working towards the transformer architecture. But before we get to that architecture, we're going to talk a little bit, like I said, about the history and I would say the context of the foundation models. So whenever we talk about foundation models, which, for example, can be GPT-3 or GPT-4, we're talking about these state-of-the-art natural language processing models that are really designed to understand, generate, and interact with human language. So to give a bit of an overview of the context of the concepts that often are mentioned when it comes to models or natural language processing or NLP, here's a quick overview that you may have seen before. And that's just to put everything in perspective. So when we talk about artificial intelligence, we really talk about, the idea of having computers or machines performing tasks with human-like intelligence. It's a very broad concept. Sometimes it's also jokingly said that AI is anything that hasn't been done yet, because if you think about it from a very, if you just look at the definition, then you could even say calculator is AI, but we think that's too rudimentary, so we don't consider that AI anymore. But that's also why you'll see it very often mentioned everywhere, because it's a very broad concept. So part of making AI happen, or to achieve AI, is using machine learning techniques. And with machine learning techniques, we give computers the ability to learn without explicitly being programmed. And we're going to come back to that later when we talk about some techniques that have been used to achieve NLP, because specifically with language, that being explicitly programmed sometimes seems like a fairly easy way to do it, but it actually turned out it wasn't. And then a subfield, again, of machine learning is deep learning. And deep learning it borrows a lot of the techniques coming from, for example, neuroscience, where it tries to recreate what we're doing in our brain. And that's also why deep learning methods like neural networks have like similar words as what we have in the brain, namely neurons. And it really is a way to understand complex patterns in data and to learn from it, and to also, again, represent those patterns in some kind of model. So when we talk about natural language processing, there's a couple of different things that you can do. In general, we're talking about, like I said, understanding, interpreting, or generating human language, and that can be done for various purposes. So number one here is, for example, converting speech to text or text to speech. Two would be machine translation. So using, any translation app that you have on your phone. I think nowadays everyone uses it. I, for example, also use it to translate a Dutch website to English or an English website to Dutch, which can very easily be done on your phone or in your browser nowadays. We have text classification, where you classify a whole document. We have entity extraction, where you can extract keywords or names from a document. We have question answering, Q&A or FAQ bots, for example. And we have text summarization, where we can generate a short summary from, for example, like a multi-page document. Corey, do you have like some use cases or case studies that would relate to one of these examples?
Yeah, I mean, I think what's really exciting about the world of generative AI is that some of these NLP tasks can be achieved much easier, or at least much more efficiently than before, right? With using some of the foundational models that you explained. So, for instance, I've seen a lot of the text summarization being really interesting. I think a lot of people who make content are worried, right? Or like, yeah, even managers like, oh, everyone's not going to go to a meeting anymore. They're just going to have Copilot to summarize the meeting, and no one's going to actually be there. But I do think those tools are really great for one, finding the information that you need quicker, right? If you want to have a summary of notes, even if you were in the meeting, it's super helpful to get that summarization. And then even if you want to watch a recording after, you can go to that direct recording. But by far, my favorite use case from a summarization point is using some of the GitHub Copilot products around summarizing, giving things like pull requests. So instead of me having to like get really wordy about the PR that I did, I can have a generative AI model basically summarize all the code changes I had and put it into words. So that's saving me a lot of time. And again, it's not hurting anyone in terms of you're not going to read my essay, you're just going to summarize it, kind of thing, which I think is great. Great use of AI and NLP, like you said.
Yeah. Yeah, and I don't know if like in Word, for example, it's already been there for a couple of years, but you can use dictate to just like talk out loud. So sometimes if I have to write something, for example, I'll just use a dictate function in Word where I'll just talk about what I want to write and it will then write it for me. But you can also do it the other way around, where you can then convert the text to speech. So if I want to see if it flows well, then I can actually also tell Word to like speak to me with my text so that I can see if it is nice. So let's talk a little bit about the underlying techniques here. Again, I'm going to go through them fairly quickly because I think the demos will be more interesting. But yeah, to understand how we got to NLP from, the developments in the last couple of decades, there's a couple of things, a couple of breakthroughs that have been important. And one of them is that, like I said, if you think about how to achieve AI or how to achieve NLP, originally, if you think about before any of these methods were existed, you can think that, oh, a language has a grammar, has spelling, there's a lot of rules to it. So surely we can just explicitly program any computer to be able to speak a language or say something. And of course, none of the grammars in any languages are very consistent. All of them have exceptions. All of them have specific, ways to interpret it. So it's really hard to explicitly program a computer to be able to understand a language. And then one of the reasons why is also that computers can't really work with text that well. So the first, I would say, advancement that happened is tokenization, where we made sure that we could represent text as numbers. To do that, we just start with the text you want to tokenize. You split the words based on a rule. You then stem, so you merge similar words together. You remove stop words, which you can do based on some kind of dictionary that you have. So think about words like the or a. And then finally, you get to what is useful for the computer, which is to assign a number to each unique token. So to visualize that, here's a diagram that shows those different steps. So imagine this as a pipeline that a computer goes through, where you have your first, I would say, phrase, the sun sets in the west. You then split that up so that each token is separated or each word is separated. Then you can make sure that all of them are stem. So sets become set, for example. So kind of the nouns are becoming the same. Subwords are removed. And then finally, you can represent them with numbers to make sure that you have a unique number for each unique word. So this way, you can already make sure that a computer understands text by representing it with a number. And one of the things that they then did with it is, well, two different techniques that were used. One, a very early NLP approach, I would say, was to recognize whether an email was spam or not spam. And a way to do that was by using what we call naive Bayes, and that's a statistical technique. And it basically just looked at different documents, and it recognized that certain groups or collections of words or a bag of words would exist in one document, but it wouldn't exist in the other document. So I think nowadays we almost use this technique ourselves. Sometimes if you look at an email, you can already see by the words that are being used that it is probably spam. And that could be something like, oh, I have a miracle cure that, will save your skin, or those kind of things.
It's always the all caps title. Sometimes I do that because it's important, and then my email goes to spam, and it's really sad.
I don't know if you have a similar thing in Swedish, but I also notice it with Dutch that it's also just like the grammar is off, like the words are off.
And then, really?
Yeah.
No, I don't think so.
Yeah. So it's always funny to see like how they try to approach it. But they've become much more sophisticated. So I don't know if this approach would still work, actually.
Do you mean the technology or the spammers?
The spammers. Both? Yeah, both. Yeah. Yeah. Right. So yeah, another technique is a term frequency inverse document frequency. And that basically just means that they look at the frequency of a word in one document and they compare it with the frequency of the word in the whole corpus of documents. In other words, for example, think of the word flour. Flour would very often be used in recipes related to baking. So because you know that flour is often used together with baking, you know that it's related to a specific topic. And then you can kind of combine that information with the word flour so that if you're looking for documents with flour, you're not only retrieving documents that have the exact word flour in it, but also maybe some like topics that are often related to that word that you're looking for. So this was mostly used for search engines to make sure that you're not just finding the exact same match, but also possibly potentially related documents. But this also reminds me of like the early days of Google where, the search results are just completely different than what they are today, right?
For sure. Yeah, things have changed on the internet. For the better, hopefully.
Yeah. Awesome. So let's go into the deep learning techniques then. And again, like some concepts that have been used in our deep learning methods that have led to where we are today. And first of all is, we had tokenization to represent our text into numbers. But then, one of the things that we notice is that, okay, we're just giving a word a specific value, but what we're really missing is, understanding, for example, how words are related to each other. So that last technique I was talking about did it a little bit, but you needed like a whole corpus of documents to be able to do that. So another way to, I would say, convert a text or a word to a numerical representation is by using word embeddings. And word embeddings solve the problem of not being able to define the semantic relationship between words. So here you can see a three-dimensional space. We see three axes, and you can see three, I would say, words that have been plotted in that space. And in that space, you can then see that some words would be closer to each other on different axes than other words. So for example, boat may be close to car because, they're both vehicles. But boat should also be close to, or should not be as close to driving as a car, because car and driving are used more frequently together than a boat and driving, even though you would use them similarly. And in that way, you can kind of see that based on different dimensions, and each dimension can then have a different semantic, I would almost say. So you can have one dimension being vehicle type, you can have another dimension representing something different, like activity. And on different dimensions, you can then see how these words would be related to each other, and therefore also understand if they're semantically close to each other. This worked really well in the beginning for deep learning methods, and one of them, which we'll explain in a bit. But just note that also this was would be calculated, I want to say, based on how often words would be used together in a text. So that means that sometimes certain words would be semantically close to each other in these kind of representations just because they're often used together, but not necessarily mean the same thing. One example being love and hate. As you can imagine, love and hate are often used together in the same text, but they don't necessarily mean the same thing. So that's why like word embeddings was a really good advancement, but not always is very accurate of their meaning. So one way that it's then used is in recurrent neural networks, which was a deep, or it still is, a deep learning method where you can also include the context of a word. In other words, you would understand a word by also looking at the rest of the sentence. So to give an example here, you would have a sentence like Vincent van Gogh, like the Dutch painter. I'm saying it
Oh
very
wow, that was
sorry.
the perfect way to say it. I'm always going to say it that way now.
Well, I don't know if you can, because I know a lot of people can't do this.
I'm not going to try it on air here. I want to try it after we're done, truly.
Yeah, it has to come from the throat. Like, it has to come from very deep in the throat. Yeah. But I also have a thing against saying it very English. So I'll say the Dutch way, which is Vincent van Gogh. Anyway, right? He's a painter. He's known for certain paintings. So if we want a model to predict what kind of paintings, so predict what comes there in that masked bit, we want the model to not just, so basically understand what the whole context is of the whole sentence. So the way that we can do that is, again, by tokenizing first. So you would split up the sentence. As you can see, we separate all the tokens, remove the filler words, we stem the words as well. So similar to what we did before. And then what an RNN does is that it processes the text in sequential steps. So first it's going to understand what Vincent is, then what is, then what painter is, etc. And finally, when it then gets to the mask, it should be able to take all of that information that it has processed to predict what that mask should be. So what is the painting that Vincent van Gogh painted? So again, let's see what that would look like in an RNN. And it's basically, like I said, sequential, where you would have an input and you would have a hidden state. So at every step, the input would be the newest token, so to speak, so the newest word. And then in the next step, that word would be part of the hidden state. So as you can see, we start with an empty hidden state. We have Vincent as the first input. And then in the next step, we have Vincent as the hidden state, and then is will be the new input. In the next step, like the third part, we see that Vincent and is are both part of the hidden state, and painter will be the new input. You can see where this is going. So finally, we get to the mask, and then the hidden state would include all that information about Vincent, painter, node, those kind of things. But the problem with RNNs is that each of those words, and let me go back because this moving thing is driving me crazy, but each of those words kind of matter equally. So even though Vincent in this case is the most important information, I would say, and then maybe a painter second, all of those tokens have the same weight in that hidden state. So even though RNNs were already pretty powerful, the problem was still that some information may have gotten lost, especially if you would have a very long sentence and Vincent was mentioned way in the beginning. Then by the time you actually get to the mask, it may be too late and you may have already lost all the relevant information. Okay. So then when we finally get to the transformer architecture, there's a couple of concepts, again, that made that transformer architecture really groundbreaking, I would say. And one of them is positional encoding. So like I said, with RNNs, we had already the context, but it could be that there were words in the beginning that would get lost the further we went down the processing of a sentence or processing of a text. So one of the breakthroughs in the transformer paper that's the Attention is All You Need paper by Vaswani from 2017, is positional encoding. And again, this was a way to encode text, so to make sure text was represented as a numerical value. But this time we have vectors, which are actually a combination of the word embeddings as well as a positional vector. So the word embedding would represent the meaning of a word. The positional vector would represent the position of a word in a sentence. So the way that you can, I would say, encode the position of a word in a sentence is by giving it, again, a number. So here's an example where you would have a sentence like the work of William Shakespeare inspired many movies. And very simply, you can put a value to each token in that sentence. The problem with doing it this way, however, is that the more text you have, the higher the numbers become, and that can be a bit problematic also because sometimes computers can consider a higher number to be more important, and you want to avoid those kind of things. So for the math nerds in the room, you can already see that the formula that they used uses sine and cosine. In other words, it uses periodic functions. In other words, it makes sure that there is a certain range of values that will then be used to assign a number to a token, so that the actual value of that index will never supersede and never be too big. And in that way, it mostly looks at the relative position of a word in a sentence without really going to extreme index values. So that's then positional coding. Again, like I said, combining the meaning of a word and the position of a word that it was in a sentence. Then, yeah.
Shout out to all the math nerds.
Yeah.
Definitely, when I learned cosine and sine, I definitely said, "Oh, I'm never going to use this again. Never going to see this again."
Yeah.
Here I am. So math is inevitable. Everyone, definitely go out for math.
Yes, math for the win.
Yeah.
Right. So then we have multi-headed attention. And it's like I said, it's attention really was the most important technique that is used by transformers. And the reason why is because it's a mechanism to map new information to learned information, and it really fixed the issue of memory in a lot of models that we had before. So remember, for example, with RNNs, we had that hidden state that included all the information from the previous, from the text, from the sentence. And by using attention, it made it a bit more efficient to find the right information at the right time. And the way that it does that is by using 3 parts that you can also find again in the attention function that I'll show in the next slide. And it uses a query, it uses a key, and it uses a value. Basically, what it does is that whenever it gets a new word, it will encode it by using positional encoding. And then that is represented as a query. The output of that is a key with an associated value. So for example, the first time it finds Vincent van Gogh in a sentence, it will grab it, it will try to find out what the value is, and then it will put that in sort of I would almost say a dictionary. So by going through a whole corpus of text, it will be able to come up with the keys and values, as you can see on the slide, where you have things like Vincent van Gogh and a value like painter. You have William Shakespeare, who's a playwright, Charles Dickens, who's a writer. So then every time that you then find a new query, for example, Vincent, you can go into that, I would almost say dictionary, see which query relates to which key to find out what the associated value is, or in other words, what the associated meaning or relevant information is. And the multi-head means that it does that multiple times. So it doesn't have only one value associated with one key. A key can have multiple values and be entered multiple times. So it depends also on the context and the information provided, what value would be most relevant at that time.
Okay, so
yeah?
I've heard you say it so many times. I'm ready to give this a try. Vincent van Gogh.
Yes, there you go.
Yeah.
Very good.
Let me know in the chat if you're impressed. That was good. Vincent, that was my best.
I'm very proud. I'm very proud.
Thank you.
You can move to Amsterdam. You're ready.
That's all that was stopping me, was being able to say that. So.
It's our entrance exam. Otherwise, you can't go into the country. Awesome. Okay. Well, again, a little mathy tangent here. But if you want to know, this is actually also in that Attention is All You Need paper. So you can fully dive into that paper if you want to know more. And I don't expect you to know everything, but you can see here that there is the attention function, and you can see that it uses the variables Q, K, and V. So that's the query, the keys, and the values. And what you can essentially see is that whenever it gets a query, it will calculate the skill dot product with a key. In other words, it will find which query, so the positional encoding of a query of a word, the positional encoding of a key, and understand which ones are close to each other, and then find the associated value to it. As you can also see, it uses softmax. In other words, it could be that a query has multiple keys that are associated with it, and it will try to find out which one has the most probability of being associated with it. And this kind of further translates into when you actually use models or language models, because sometimes you can mess around with how creative a model can be. So based on a query, like which keys would be associated with it. So for example, do you want it to really only go for the key with the highest probability, or do you allow it to also go for keys that might be somehow a little bit less related to it? So again, it's not very fixed, but it just makes sure that you try to find like the top results of queries and keys that are related to each other to find the relevant values, to find the relevant information. We're almost there, I promise. I hope you're still
You're
with
really
me.
hyping up this demo as well. Like it's going to be the
Yeah.
grand finale of all of this.
Exactly. Like I hope people will be a bit more interested in the demo. Right. So then we get to the most, I would say, heavy picture that we'll have here. And that's a transformer architecture. And this is again also taken from that article, right? Most importantly, what I want you to see is that there's two parts to it. So you have the left part and the right part. The left part, so to speak, is the encoder. So that part is responsible for processing any input sequence and creating a representation that captures the context of each token. And you can already see here that it has input. You can see it uses positional encoding as one of the first things it does to make sure that text is basically converted to, let's say, a number. And then it uses multi-headed attention to kind of create that key and value table that I showed you before. Then you see on the other side that we have the decoder, and that generates the output sequence by attending to the encoder's representation and predicted next token. In other words, you see again in the output that you have your output, so you have your text. So for example, that mask, it is, again, you first going through positional encoding, so making sure we convert text to numbers. Then also, again, it is we'll use multi-headed attention to make sure that we have a query. And then finally, the information from the input and the output is put together. So that whole, I would almost say like numerical representation of the text you're looking at is put together to make sure that you can find which query is relevant for which key, and therefore which value is relevant for your context. I think that's all we need to say about the transformer architecture, but hopefully you understand a little bit more about like what is happening when we're working with foundation models. What you'll also see when we go through the different foundation models that Corey will show in a minute is that some of them, well, you have many different foundation models offered by many different providers as well. And if you go to the model cards of different foundation models, you can see that they sometimes have different architectures. So some of them might have, for example, both parts of of the encoder and decoder. Some might only have one part, might only have, for example, the decoder. So by understanding the transformer architecture, you kind of understand the base of that a lot of models are then built on, but know that some models are built a little bit differently. Okay, I think that's enough theory for now. Corey, do you want to take us through the model catalog?
Yeah, let's do it. As you have been speaking, we're going to demo the Azure AI Studio. I saw some questions already about which models are available in the AI Studio, getting access to this and things like that. So seems to be very excitement. I'll answer the first question immediately about what models are available because the answer that I have is a lot. So we're continuing to add new models to this, and I'll go through where you can find those models. But it'd be really hard for me to list all of them. And also, like I was mentioned, this is in public preview at the moment, so it's preview, which means that this whole experience could change tomorrow, or we might add new models, or we might add some new features or new opportunities to allow you to build better with generative AI models. So if you're watching this in the near future, hopefully most of this will probably look the same, but there might be new features and things like that. So don't come at me, don't find me on the internet saying that I showed you something wrong, because I definitely didn't. This is what it looks like today, which is a new exciting thing for sure. So first you'll see that's and this is me zoomed in, so I'm sure whoever built this user interface is hating me right now, because this is really all supposed to be on one beautiful little thing here, row. But we also see the projects that we have built. But let's get down to what we're here to do, is looking at the foundation models that are available within the AI Studio. And we can do that currently, at least, by clicking on this Explore button. and this will show us the model catalog. And what's really nice is as things get more announced in terms of adding new models, they actually get shown here on the announcements and this nice little blog post kind of explaining to you what the models do, why they're important, things like that. So like I said, we're continuing to add new models. I've heard that we already have some in plan coming up. So you'll probably see these in the new announcements coming up as well.
Yeah, I
But
think Mistral's added only 2 weeks ago or something, right?
yeah, I think, yeah, very, very recently. So,
Yeah.
and that's a great partnership. So you'll see a lot of the models that you might say, hey, I read something about this new model coming out. There is obviously some time in between you reading that blog post on, whatever.news.com and it being here in the model catalog. But most of the models, especially if they're open large language models or available publicly, will find their way in here. And you'll see that because we have a few different collections already. So we have the Azure OpenAI, which I think a lot of people are interested in, which is your GPT-4 models, GPT-3, 3.5, things like that, as well as Whisper and embeddings, which are super important when we're talking about building applications. Then we also have Meta. We're going to look at Llama 2 specifically when we talk about fine-tuning, because it's a great model to get started with fine-tuning with. But then we also have Hugging Face models. So let me know in the chat if you ever used Hugging Face before. If you've done anything in data science or machine learning in the last, I don't know, 5 years, you probably have come across Hugging Face at least once, because it's a great resource to finding models. And we have them all sort of integrated here in terms of you being able to find them and deploy them within Azure. So super simple experience. And then we also, if you want to get really really risky, not risky, that's a bad word to say, but if you want to be a cutting edge of things, we also have the Microsoft research models that are out there. So these are things that come up from the research org of Microsoft that are either experimental because of their size. So we have things like the SLMs, the small language models that are out there, or they're the tasks that they are doing. So again, that's really cool. And then what was also mentioned, things like Mistral are out there and Databricks as well. But one of the things is that when you look at all these models, like I said, we have a lot. I think, let me see, maybe they're showing me a number, maybe not. And this number grows anyway, so would be worth this to show you this now. Is that, okay, which models should I choose, or which ones should I get done? Which ones will help my use case, right? And we have these things, and this is actually similar to what you might have in a Hugging Face experience as well. We have these inference tasks, and this is a good way to filter out what these models do well. And obviously, there's models, things like some of the large language foundational models that are out there that can do multiple things pretty well. And you'll probably also find them when you search on the task. And a lot of these are somewhat self-explanatory if you've done some work in this space before, but just to cover some ones that maybe aren't as obvious, we have things like token classification. So if I click on that, that'll show some of the Hugging Face models that are there. And this is actually, if you want to classify and this is great tie-in, Mary Jo, to what you said, right? So if you didn't have this theory before, this would not make sense. But like tokens, right? We all know this from what Mary Jo said about how we divide things into tokens. So what this actually allows us to do is classify those tokens. So if we said Corey presented today at Microsoft, we can use a model to say, Corey is predicted to be a person, Microsoft is a location or even a company, and even like an adverb presents or a verb presents, right? And this could be really interesting for you if you're trying to process a large amount of text or find those interesting parts of that sentence or expression to use in your application, right? These models are really great at doing that. And again, they're really specialized in this type of work, rather than you're using a generalized model that you think could do all of it through prompting and things like that. You can use a model that already addresses those things. And another one, also tying to what Mary Jo had said, is film mask. So these models, if you take, I think you even had an example of this with the RNNs. You had, like, let's say the chicken, or so let's say, sorry, I ruined that. The blank crosses the road, right? Mary Jo, what would you predict that being?
I don't know. Was it a cow? I don't know.
Well, so I mean, right, the model will give out predictions. And maybe chicken, because that's like what it's been trained on, and chicken could be a high probability. But then it'll probably also suggest things with legs or things that are capable of crossing the road. It won't say, I don't know, the airplane crossed the road. And it's using that because it's giving the mask. So the mask is the kind of fill in the blank, and then the model predicts on those sorts of things. So also a good way to use these type of models, maybe when you're processing a lot of data or information, and giving that those clues. But then we also have, conversational models, which is not to be confused with chat completions. These would be kind of mainly when we're talking about chatbot experiences. And then the chat completions, which is the models that you're probably hearing most about now, like Llama 2, Chat, as well as the Mistral. And I think I wish we had a French person as well. They could tell me how to pronounce Mistral perfectly exactly as well. But we only have Dutch and Swedish here, so we're going to go with the complete English version of that. So you'll also find those models there. And if you want to find details on those things, you can find the task, right? Just the chat completion. We have some descriptions of what they do. If they do our Hugging Face models, we'll have a link directly into the Hugging Face card as well, so you can see that. And then you can, really one-click deploy and getting those models into your applications. I see in the chat. Oh,
yeah,
go
sorry.
ahead.
There was right there, because talking about languages, as you can see at the top here, it also shows you which languages it supports. So this specific one will support English, but sometimes they support multiple languages, or sometimes they support, they're created specifically for another foreign language, like French, for example. So also know that you can filter on that too.
Perfect. Yeah. Speaking of French, Omar in the chat has mentioned that he is French. So Omar, please rate my Mistral pronunciation for sure. I'm trying to be as global as possible here in this in this workshop. Okay, so that's the model catalog. That's going to answer a lot of the questions that you have around which models are available. Comparing the models, we have this. Oh, 8 out of 10. Thank you, Omar.
Wow.
8 out of 10 on that.
You're doing good today.
Cool. So we also have these benchmarks, which will probably be similar to what you might have seen if you look at other benchmarking measurements that are out there. But we have it all within the AI Studio, so you don't need to go find the website that you forgot what it's called, and you need to go find the link to explain those things. So we have right now we only have 2 tasks. Like I said, that could be outdated. Tomorrow we might have other tasks within here in terms of comparing them. But we can do comparing, let's say, question and answer, and we can see all the especially the large language models here that can do those tasks. And then we can select and either compare those models directly. So we can see some metrics like accuracy in terms of the response, fluency, like how well the responses are presented essentially, or like using proper grammar and things like that. Which I think it will be a great way to start looking at comparing the models. And then we also have some of the traditional benchmarks that are out there. If you're familiar with some of these tests that basically test, I guess, or analytics or ways of benchmarks to compare the models, like Open Book. And I think my favorite one, I don't know if you heard of this one, Mary Jo, but Hella Swag.
Oh my God,
the,
no.
yeah,
What is this?
I forget exactly what's in the Hella Swag data, but that's one of the popular ones. So that's also we should see here with comparing them. Honestly, I think especially when we talk about some of the open LLMs out there, when people ask me like, how do I choose? It's very much also getting a sense of your use case. And like I said, looking at how to deploy these models, it's rather easy to, let's say, deploy Mistral 7B and a Llama 2, and maybe even comparing them to what you think your users will be asking or how they're interacting with the model to get some true benchmarks. But this is a great place to start for sure.
Yeah, and also maybe good to note that there's, of course, different ways that you can evaluate, and I think Corey, you'll talk about that as well. But one of the easiest is, of course, using the benchmarks. You can also have your own metrics that you want to use to evaluate a model. And often you also want a kind of like human evaluation to evaluate a model. So there's different kind of layers to evaluation. And this is just showing you like the quickest way and the easiest way to do it, to get a first glimpse of which model you want to use.
Yeah, for sure. And I mean, not to add too much spice to the workshop, but there's also heavily debates, right, about some of these benchmarks, especially as they go on, right? We're using the same data. Does the model pull in it from their training data, things like that? So this is a good place to start for sure, to know and comparing them. Like I said, you're probably not going to see massive amounts of differences on certain models, but you will see that in comparison to different data sets or that are out there, what it's used for or benchmarked against. So that will also help you. And what I would employ people to do is actually look then at like what HelloSwag is, because then you might know, oh, okay, this is very similar to what I'm going to be using it for. And if it benchmarks well in HelloSwag, it might be a good place to start for sure. And then this last part, which I think is it's a new feature for me, because last time I don't think I actually saw this in there. Maybe I overlooked it, but we also have this prompt catalog, which on point Raj has actually asked about in terms of adding templates to your ways that you interact with the model. So this allows you to get really started in terms of common use cases that we have seen using generative AI models and large language models specifically. So for instance, we have this like advertising summary. So we'll give you these like example system messages, which are, if this is the first time you're seeing this term, really kind of meta prompts or instructions to the model to act a certain way or behave a certain way or answer the questions in a certain way, and also give the model types of roles. So in the case this is talking about some sort of assistance, you're going to present advertisement, videos, or products, and then you need to describe what's going on in them. And then we actually have a video here, which I'm not sure if that's going to work right now. Where I'm sure. Oh, it is. Oh, wow. Can you hear that?
I can't hear it now.
There's
But
some music.
Oh, great. But to
Yeah.
answer Nahal's question from the chat, if you don't see the prompt catalog, it's probably because we're on like a preview of the preview. So we might see some things that will be rolled out in near future for you. So if you don't see it, don't worry. It could be, by the way, that you have to enable certain preview features. But yeah, it will probably come soon.
Yeah. Like I said, this is a glimpse of the future.
Yeah.
For sure. So yeah, if you don't see anything that I show you or it looks a little bit different, rest assured you will get this experience one day. It may be even better than the experience that I'm having. So who knows? Because they're constantly getting feedback and improving things for sure. And you also see like modality, things like that. So if we go back to the slides, because we're going to transition, we got about 10, 12 minutes. Let's talk about fine tuning first. And I want to actually talk about it via the slides before I go into the actual demo. Great job. So if we go into the next one, and understanding when to fine tune is a big question, because we get that quite often, right? We have this concept of fine tuning. Some people don't know what it is, where to start. So first we'll talk about what is fine tuning. And if you think about fine tuning, it's really like these models. I want to say that, and not to give them human-like features, but they're probably B+ students on a lot of topics, right? So they're really good at doing a lot of different things, but they're not necessarily A+ at specific task per se. They could be satisfactory to your use case, but maybe you have a very specific thing that has a lot of rules, or different subsets that if you wanted to build out a whole prompt for that, it'd be very, very hard to do. Or I think we talked about languages, many different ways languages today, but let's say you wanted to do a model. There's actually a GPT SWE out there. So big shout out to those people who made that, but it's a GPT model that has been fine tuned specifically for Swedish. So this is a very specific task, speaking Swedish. And then you would have that model. And even though you get Swedish from the foundation GPT-4 model, that's probably really good Swedish, we have this specific model and specific tasks. So if you think about first, when you want to start what fine tuning is or why you would do it, you need to understand if there's a specific task that you think the model should perform better on than what it's currently doing. Fine tuning is a place to look at, but later on now we'll talk about like some of the requirements and when to do that for sure. So if you go to the next slide. So yeah, so fine tuning, there's ways that people get confused with what fine tuning the result is, because we have things that are ways to enhance the prompt or enhance the responses of the user or what the open model is giving you. So we have things like RAG, which is, let's say we have data somewhere stored or in a PDF. We can augment the prompt with that data And then we can add that. So if it's something, let's say I am asking about it, we can take all of my, let's say, user information or user history, let's say shopping history. And then when I go to a shop assistant and say, I would like, new pair of pants, it's going to augment that prompt with, oh, this is Corey and he has bought X, Y, and Z. He's customer ID, loyalty number, whatever. And that could be very useful for the model. So this is a good way if you want to enhance the responses. And also even prompt engineering. So all these techniques around few shot, many shot, things like that are great ways to enhance the responses that you're getting from the model. If you want to change the model behavior, which is what fine tuning does, it's actually customizing the model again for a specific task. That is when this is when that is actually a good use case for that. When you have, again, specialized task, there's clear sets of rules. What I'll show you in today's demo is like using it to convert plain text to SQL. That's the foundation model can do, but maybe not at a high level. So if I have a huge data set that has those, response and input output, basically, then we can change the model behavior to improve on their SQL, for example. So to run with this B+ student analogy, because I got someone that's at least in the chat that likes it. This would be like, if you're good at math, because we said, math, shout out to all the math fans out there. If moving from algebra to calculus, yeah, it's difficult, but it's still math. So if you've got some of those skills of math, then sure, you'll probably be pretty good at it. And I know probably there's math people who are cringing right now, but you probably have some similarities, right? But if you want to take, let's say, math and learning French, these are two very different tasks, right? And so when we're talking about enhancing prompts, maybe we are talking about changing the subjects a little bit, or changing the area of focus within a subject, while fine tuning is changing the subject entirely. And even talking about some of the RAG techniques, like let's say we wanted to study French literature, but we wanted to be specialized on this one author. That's what enhancing the prompt, right? We give all the model all of the details about this author, but while we're not changing the entire subject of French artists or French authors, for example. This is really global presentation, so I love it. So now if we go to the next slide. So when to fine tune is another really important question to answer here. Primarily when you have enough data that exists. Enough data as this is the classic data science. Like, when do you have enough data? When you stop asking if you have enough data, right? So it's like, really, essentially, I can't give you an exact number. I think at the time now, the minimum, absolute minimum is 10, but that's not to say that once you have 10, you have a good fine tuning data set. But it's just that there's no point of even like using any compute resources to fine tune with less than 10. But if you want to like get a good metric or heuristic about thinking about these things, the higher or the more sophisticated the model, so let's say a GPT-4, the less data you necessarily need to fine tune the models. But that's not to say that you only need 10, right? So we're talking, I'll tell you a model that data set that I've used. And I believe it has 78,000 examples or something like that. So just to give you an understanding of the scale of this, because sometimes people want to fine tune it, but if they don't have the data available, you're not going to actually get the results that you're looking for sure. And then when also you might want to look at performance is particularly when data is the best expression of what you're trying to achieve. So like I said, in this example, I'm going to show you, I'm going to use text-based text, like a regular text, into converting that to SQL commands. And that's really hard for me to write in a prompt, right? I can't just explain how SQL works completely in a prompt, right? So that's another reason why data is a good way to express that. And then cost, right? You can use a smaller model to make it mighty, because you can enhance those features and those focus there. So we'll get into the demo now, because I think we're short on time here. But I want to show you a little bit about fine tuning. So if you go ahead, a lovely producer in the background.
Yeah.
So to do this is actually going to be in the build section, which so right now I have a few projects here. So if I go into one of those and it's going to load up, I will see, and maybe you don't see this on your side at the moment, but I'll see this fine tuning option here. So what I can do is click on this fine tune. I have one already done here, which is Llama 2. But just to show you what the workflow kind of looks like here, I can do fine tune. Right now in this region, we only have available in the AI Studio the Llama models to fine tune, but of course this will change. But I can go in, I'll choose which to continue the fine tuning. And then which is really important here is actually getting the data into the model. So I have existing data that I already have, so I can show you what that looks like. The SQL create context, but then you also have to do things like selecting the column. So which one is the prompt? In this case, is the question, and then the completion. So what the response is from the model, and that is the answer, right? So I can go in and just to show you what this data set looks like. I have this in Hugging Face, or this is hosted on Hugging Face, and it's just SQL create context. Like I said, it's 78.6 rows, so quite an extensive data set. And you can see, right, it has the answer here, which is in SQL, and then the question, which is what is the user asking, right? So in one case, like how many heads of departments are older than a certain 56, then that will convert that into a SQL command. And Llama 2 can do this, but not as it to the level that we would like it to in this particular use case, that's per se. So I can go in, I can do all of those things. I can also split the training data set. So this is a good data science practice, whether you're splitting the training data or you can provide your own validation data. And this to show you, right, this is actually getting into the world of traditional data science, I guess, or traditional training models. Then the one-click deploy and start working. So you get more control here if you know what to do with it. If you don't know what to do with it, then it's more responsibility of where things could go wrong. So again, knowing these terms, knowing how to divide these things is a good point. And then I can, again, if I do the training split, I can do that. And then even more data science-ish, right? We can do things like batching. So how much data goes into the model for training? How quickly it draws conclusions, essentially, with the learning rate, and the epoch, like how many runs it does of the data set before making its predictions. So again, this gives you a lot of control, but I think that quote, well, great responsibility comes great power, or great power comes great responsibility. Yeah. One of those things, right? So this is giving you great power and you need to be responsible with it. But just to show you a bit about that flow. And then what's really nice is after these models are fine-tuned, right, you can deploy them as they were regular models. And I don't know what happened to my, so deploy them as regular models there. You can work with them in the playground. And this custom, fine-tuned Llama 2 is mine. This is my little model in my little Azure Studio. And again, no one has access to that unless I allow them via application or via the API. But that shows you some of the steps of fine-tuning. So why you would do it, when you would do it, and now the how you do it within the AI Studio. So if you go back to the deck, I guess we're almost due with time.
We actually have an extra half hour, Corey, so we're fine.
Oh, wow. Okay.
Yeah.
All right. All right. So great. Well, we do have some knowledge checks and probably a lot of questions as well. So let's go to the next. Well,
slide. One of the
go ahead.
One of the things I also wanted to highlight is that you showed the data being expected to have a specific schema, right? So it also depends on what you want to fine tune your model on I don't know what the word is, which task you're selecting to fine tune a model, what the data will be and what the structure of the data should be. And you can also find this, it's it's prescribed. So you also know whenever you have a data set, what kind of format it should fit in before you want to fine tune it. So it's definitely good to then clean up your data, make sure it's in the right structure. And I think that's also a question that's often asked. I don't know, Corey, how you think about this, but if you indeed have data, what do you think you should what should you do with data to make sure it's good for fine tuning? Because you say enough good data exists. What are some of the things that you should do with the data to make sure it's suitable?
Yeah, it format technically, right? Is this JSON-L file type? So that's
maybe you can show it. Sorry, it's there was a question.
I see that question. Yeah. This is actually it's not going to be like that exciting. Let me see if I can show it in. Let's see if I go to fine tuning, but it's basically a giant JSON file, which is not very attractive to look at. But if you really want to see that, happy to do so. And I think in the platform we can actually make it look nicer. So it gives me this data preview, which is also a very nice looking data preview as well. Um, so that's not exactly what you might be looking for, but I do would say definitely go into this Hugging Face. You could then, let's say this is called SQL create context. So this is, you can download this directly. I think I actually need to convert this to JSON-L, which is not hard to do. So this one, I think it gives you the JSON file. Yeah, this is just JSON, but JSON-L is like the list version of JSON. So it just kind of, I guess,
Yeah.
condenses it. So that's another thing. So if you do see any good data sets that are out there, like I said, this is a good one because it's input output. So I have an input, which is the question, and the output is the answer. And that's currently, at least for the models that we have Llama 2 on, is the only kind of format that we accept. So while there might be other inputs, things like that could be useful for training other models. For fine tuning a LLM and the AI Studio, this input output is the format that we're looking for. And I also saw this question about LoRa, LORA. So that's exactly what we're doing. And LoRa is basically taking the weights closest to where it makes its predictions and altering them with this data. So you could think of weights and layers and things like that within a model. There's multiple ones trained early on, adjusted for making predictions, and then basically at the last level of making that prediction is where you're basically adjusting or fine-tuning the model. So we're not doing a full fine-tune per se, but only on that level. So thank you, Omar, for that question. That's a good one.
Yeah. And I think now that we were looking at the data as well, like what is a couple of good practices? Because I think some people mentioned it as well. What do you do, for example, against adversarial attacks? I think one of the, like I would say, attacks that you can expect is that people will try to do like prompt injections to get to your training data, especially if you fine tune a model. So one like very best practice, a very simple one, is to just not include any PII data in your data set. So even if you're going to fine tune a model based on like HR queries or something like that, just make sure you're not using the raw data as is, that you're not just like exporting those emails and throwing it in the model, but make sure you clean it up, make sure you remove any PII data, and potentially also just look at how you can consolidate certain queries to make sure that not like specific queries are not overrepresented in your data. So really make sure that your data set is like clean and like good representation of what you want it to do.
Yeah, that's a very good point. And, we continue to add different tools that are out there. I know we have, I think it's called Prompt Shield now, tools around that both from a content moderation as security, that even fine-tuned models, when you are fine-tuning them, they still have access to or still utilizing within Azure. So definitely make sure your data doesn't have that type of information. But we also, even if you fine-tune a model, I guess the Azure security hug, or the actual in terms of content and security, also would be applied to your models within, even if they're fine-tuned.
Yeah. Could you also show how to deploy a model?
Yeah, so I already have one deployed, but let's see if I go cancel here. But so this model is just going to tell me that I've already have it deployed, but it's actually here on this deploy. And so we have this pay as you go type model for the fine tuned models. So you go there, you'll get a little notification in terms of, if you have a model in the marketplace or where you have this deployed, then you're going to get a deployment name. If you're definitely deploying multiple fine tuned models, like make them good names. Because like this is not really relevant to me. RJRP, like I'm not going to really remember that. You can see later on, I'll show you that you can see what it's been trained on and things like that. So that's one way, but save yourself some stress and just name them good things. So this is it just alert me that this is going to be, it's already deployed. We can also open this in Playground, and depending on the mode that you have, you can also show how this interacts with the model. So right now I have this in chat mode, which is actually interacting with I put here regular, so this is like the standard one. But if I wanted to do completions, this is actually going to replace that with the fine tuning, so I can do comparing the fine tuning to the regular or the standard Llama 2 model. I got this question. See this question. Define good name. What makes a good name or a bad one? Mary Jo, maybe why don't you take that question first? Because that's a deep question.
Well, yeah, I think it's also, so you have to realize there's two parts to whenever you deploy a model. You have your endpoint and then you have your deployment. So an endpoint is really that, I would say, like API, that URL, in other words, that you will call from an app to get a response. So that's important to know, because the endpoint may therefore be kind of like visible to the outside. So make sure that that doesn't have like any, I don't know, information that you don't want it to include. But it should also therefore be, I think, globally unique. Maybe region, but I think it's globally unique. So for an endpoint name, make sure it's unique and it means something to you, but it's not necessarily revealing any sensitive information. And with the deployment, I would say that should be specific for the model that you train. So give it any information that tells you what model it represents, because you might switch between different deployments, between different fine-tuned models, for example, when it comes to the endpoint. So the endpoint is the integration with the app. But if you want to switch between models that the endpoint uses, that is deployed to the endpoint, you can do so. So make sure that then when it comes to a deployment name, it shows the model information in some way. I don't know if
That
that
was a
one has to be
great.
globally unique, by the way, that deployment name. I don't know if you know that.
No, I don't think so. But it does say it gives you these, name templates before. So
Yeah.
there's probably some logic to what it gives you those names. But to your point, yeah, maybe you might forget which training, data set that's been on. So we actually show that as well, and the base model, and then even when it's been completed, things like that. So you will still have that visible, but like you said, it makes sense because a lot of times what people are doing in terms of applications is, to your point, will like deploy multiple fine-tuned models, and maybe in an application route the request to based on what the user has said to a certain fine-tuned model, and yeah, managing that from endpoint to in the studio, great way to name things for sure.
Yeah.
I also see this question of why did I use Llama for the model instead of the Hugging Face text to SQL model you showed? So there's a couple of reasons. One, for the sake of this demo, fine tuning, we only have these Llama models available in the AI Studio. You can actually fine tune more models and within ML Studio, which again is kind of closer to doing customizations and training your own models as well. So that makes sense why those features are there. And you can see which models are available for fine tuning in the fine tuning task. You'll see here like image classification. I can fine tune these things, image segmentation, things like that. So yeah, to answer the question, I used it because that's what I can demo right now in the AI Studio. And also, I think that SQL data set is a really good data set because it's very clear in terms of question and answer, which is, again, kind of the format you want. And it has a lot of data, 78,000 rows. So yeah, that's kind of why I chose all the things I've presented to you. But great question for sure.
Yeah. And then we see a different question about the capability to export a fine-tuned model. And I think I saw a similar question before. I don't know if you can actually export the model itself. I don't know if you know that, Corey.
I don't think so. I have not seen that feature. Perhaps that is there. And but yeah, I can't answer yes or no exactly if you can export the model.
Yeah, because I think that would also depend on the format of the model. But what you can do is use it outside of the studio by deploying it. So that's for both also the I would say like the foundation models as well as the fine-tuned models. Both can be deployed to an endpoint. So if you want to use it elsewhere, you would use that endpoint to basically call the model from any other application that is able to call an endpoint, essentially.
Yeah. And I mean, I guess the use case for like downloading the model, one of them, I guess, is if you're trying to like work with it locally, which that's I know being a big push. A lot of the tools that are out there, especially if you want to work locally and then deploy, which I would imagine is some features that we're looking to integrate but I don't know exactly now if you could train and then export it out. But this is definitely your model. Again, it sits within your Azure environment, and no one has access to it other than you. And you can delete, or, restructure whatever you want. So it's not like it goes into the model hub or something, and other people can use it.
Yeah. And then I also see a question about how much it will cost to deploy a model, and that's based on the like the VM size that you choose when you deploy it. I don't know if Corey, you can show that again if you go into the deployment wizard.
Yeah. So I think let's see, build.
Maybe you could do it for a foundation model and to deploy it.
Let me see if I can. Um, let's see. So it normally has. I mean, this is going to be in Swedish crowns, so it
Oh yeah.
doesn't gonna really, unless you were paying in Swedish crowns. But yeah,
And for
it will
Debbie,
show
you're
you.
not in the euro, yeah.
Yeah, which is a very small population. So the 9 to 10 million people who might be interested in Swedish crowns, this is what the pricing is. But you will see the pricing in there. So you'll see these offer details and things like that. So you have things like the fine tuning job, the pay as you go inference. So whenever you're getting you integrate or interacting with the model, will all be there, so you can see exactly what you're getting
Yeah.
yourself into when you deploy.
And maybe you could show the same. So if you take a foundation model and then try to deploy it.
Yeah, let's see. Exploring. Let's go to our friends in Mistral, as we know.
8 out of 10.
Yeah, let's see. We go here. Deploy. So this is the real-time endpoint. And then to your point, right, you can choose the VM. I don't have anything saved here, but this is where you'll
select an AI project first, I think.
Oh yeah, but I will also not. It's gonna show me. Like I have the no dedicated quota. This is embarrassing.
Sorry.
Thank you for embarrassing Nash.
Sorry.
But yeah,
but yeah,
you will also
because,
see the price now.
Yeah, because the AI project is created within a specific region. So that means that you first select the AI project, and then you can see the VM size. And the VM size is available will depend on the region that your AI project exists in. So then when it comes to the cost, like you'll be able to see the VM size, and per VM size, it shows you what the cost will be to have it deployed. In the case of foundation models, when you deploy it, like I said, it deploys to a real-time endpoint. So it's a good question where you said, like, what does it cost per hour? Because you should know that a real-time endpoint is always on because it uses container technology underneath. So you always pay for as long as the endpoint exists, not necessarily also for it's not like a VM that just spins up and like shuts down whenever you need it. It's always on. So just make sure that you are aware of it. I've had it with like a lot of demos that have created too many demos, and at one point I am out of budget very quickly. So make
Welcome
sure.
to my life.
So make sure you.
Cool. I think we have the knowledge check questions as well.
Yeah.
That would be probably a good place to finish off, because this is a Learn Live session, and we definitely hope you learned something from what we said, but we're going to do a little knowledge check to see if you actually did learn something.
Great. Okay. So let's see. Let's go to the first question, which was back to the theory. Which of the following techniques is used to determine the importance of words in a document within the context of a larger collection of documents? So the options are naive Bayes, TF-IDF, or Word2Vec. And to answer, you can scan a QR code, or I see that the link has also been shared in the chat, so you can use that to vote. I'll give you a couple seconds.
This is where we played the. Oh, I like how people are just throwing it in the chat as well.
Yeah, we can also do that.
So the thing is, if you're wrong, then very risky move. But if you have confidence, I respect that. This is where you play the study music or whatever.
Well, I'm also thinking of the Kahoot music. I don't know if you ever used that.
Oh, you know what? I can't hear it right now, like in my head, but I know when that happens. Oh yeah, that's the Kahoot music. I know. Yeah. All right, so a lot of people saying B. That seems to be a popular answer. I hope you're right. Let's see. Reveal the answer, Mary Jo.
Let me get there. It is indeed B. Yeah. Very good, guys.
You said people weren't listening to your theory. But look, they were.
We went through
Totally.
it so quickly. I'm impressed.
Yeah,
But
really
yeah,
good.
just remember, indeed, this is comparing a word to like the frequency of a word in a large collection or corpus of documents. I didn't mention Word2Vec, but it's actually just a technology used to create word embeddings. And the naive Bayes, is, remember, just is a technique used to, for example, recognize spam emails, and that's just based on a bag of words. So whether specific groups of words or collection of words are used in a document.
This is my favorite part of the streaming is that because people can pause, move around as they watch. So people come in at like we clearly already revealed the answer the B, but it's just because they're probably watching it at a different time. But I love that though. I would be that person. B. I know what it is.
Yeah,
It's great.
especially after giving the answer. Yeah.
Yeah, for sure.
Okay, next question. What type of neural network architecture is widely used for natural language processing tasks and has been instrumental in achieving state-of-the-art results in various language-related tasks?
That's a long question.
It's a long question. I almost want to
But
give a hint, but I feel
no
I'll
hints.
keep it
This
to
is
myself.
too easy for people. Okay, we see a lot of C. We see transformer. I appreciate people who write out the entire answer as well, not just giving me the letter. That's
Yeah.
bonus points. So Shubham, thank you for writing transformer. Jason says A, so we got a little bit of diversity here, which is good. Shubham, why did you mention split C then? You just you wrote transformer, and I love that you wrote transformer. Isn't C a type of A? Oh wow, Maria, that's
Now we're
a
getting
deep.
yeah,
Yeah,
philosophical.
yeah. Let's stop the recording now.
Yeah. I
Let's
think
have a discussion.
I wouldn't say so because I don't think transformers have recurrence in them.
Yeah,
Um,
I wouldn't necessarily agree with that, Omar.
yeah.
I think maybe I see where you're coming from with that, but
They're both
um
deep learning methods. That's true. That's where I also see indeed like some of the confusion.
okay, so we got a few C's, a few A's, and a few no idea. I appreciate your honesty, Jorge, as well. That's really good. So it's C.
Yeah. And to be fair, I revised the questions and I wrote this module a while ago, and I also had a moment of doubt. So I understand the doubt
Ooh.
between A and C. But because A was like I would say one of the first breakthroughs when it comes to neural networks, but like C is really the latest one that has, I would say, completely transformed the field.
Transform the field, did it? The Transformers.
Transformers, yeah. See what I did there?
Lovely.
Okay, next question. Which of the following foundation models available in the model catalog is likely most suitable for text specification? Ooh, we didn't really talk about
I
this.
feel like really, but this is going to be a grab bag because I didn't actually
Mm,
show. I should have, had the demo to talk about that. But this will show who's, um, good at either searching for it or have experience
very
doing
quick
this.
search.
Yeah,
Yeah.
or whatever. A lot of A, a lot of Berts. That's
Maybe
good.
someone uses ChatGPT in the background.
Yeah. Who knows what they're doing out here to get all of these internet points are being right. Llama is the only one available, right?
For
No, and
fine tuning, that was the case, I
for fine
think.
tuning, yeah, to be clear on that.
Yeah.
But there's many models available in. We see here Azure Machine Learning, but also the AI Studio, which I showed earlier. I thought we were going to change that, but I think I missed that one.
Yeah.
A or C, Ginny, I like that. Play the odds are in your favor because you've guessed 2 out of 3. So
And it's
well
also
done.
mean, right? Like it says most suitable, so it doesn't mean that they're not able to do it, but
Oh yeah, I know. But
yeah.
this is a good point actually because I think some of the inference task, right? Like I said, there's obviously overlap on some of the ways the models work or what tasks they can complete. But the inference task, it really kind of shows, helps you find the ones that are quote unquote most suitable or not specialized per se, but are perform really well on those specific tasks. So I think that the inference task filters, even though some of them are obviously text classification, I know what that is. It's a great way to find the models that are performing best in those tasks for sure.
Yeah. I see someone ask ChatGPT.
So it's C. Oh my god. So if we say that it's not C, then ChatGPT
Well,
will find us.
well, then I can say like maybe if you tried Copilot, it would have been a
Yeah, there
better
you go.
answer
Oh
because
my god. It's A.
yeah, it's A. Yeah, so I think let me see if I actually have that slide secretly hidden somewhere. No, I don't think so. Oh, here we go. Here we go. So this is in the Learn module if you want to like reflect on it later, because this is a lot of text. That's why we didn't really present it. But
Yeah,
just so
there you
you
go.
know that we have there's again, like they can do multiple things, but there's some things that some can do better based on the underlying architecture. So BERT, which stands for bidirectional encoder representations from transformers, which is a mouthful, actually encodes from before and after a token. That's the bidirectional part. So it doesn't just look at the like what comes after, what comes before, but it does both. And that's why it can be good for text classification and question answering. GPT is really trained, like it's, I would almost say like its main task is to create coherent and contextually relevant text. Because of that, though, it can actually do a lot of other things well as well. So like some things that GPT is really good at were sort of accidents. Like I don't know if you know that, Corey, but for example, translations. No one expected GPT to be that good at translations, but it is.
But
And I
like I
think
said,
that
it's a B plus student, which I hope
yeah,
in the future,
yeah.
no one finds that quote on the internet, and
I think it's still a
but
great analogy.
okay.
Yeah. But yeah, so that like again, like to say it's not what it was mainly trained on, right? But it's still like something that accidentally is also really good at. And then for Llama, it's also one of the things is that they sometimes use different training data that can also influence what they're good at. But Llama is also for text generation, chat completion, so kind of similar to GPT. And then another example is the T5 because it's 5 T's in the name, which is text to text transfer transformer. And that's just great for converting text to text. So, for example, translation specifically. But again, that's not to say that others cannot do translation, but that one really has been designed for translation. Let's go back to the questions. Let's see where we were. Here we go. So now we get to the fine-tuning questions. When fine-tuning a model for entity recognition, what type of task should the foundation model be fine-tuned on? Is that
And
text?
I
Yeah, go.
definitely talked about this. I didn't use the term entity recognition, but I hope some people picked up on it.
Yeah.
This is
It's kind
also
of
a free question to search for.
yeah. But it's kind of mean because I think with like a lot of these things, you have a lot of, I would say, very technical words to describe what you mean. So entity is a very NLP technical word, I would say. Um, so it's kind of like if you know a little bit about NLP, then you can kind of infer it.
But fortunately, we got a lot of NLP theory from you and concepts, which shows why this is important for just not only being able to click and deploy models, but having that background, having some knowledge, foundational knowledge, if I want to go with that, is important, right? It's super nice to connect to those things. So we got a few people picked up on what I said. A and B are very close, right? Obviously, C is like that throwaway. No one's gonna pick it, but it's neck and neck on A and B. I'm not gonna Shivam. Can you Shivam, if you're still there with us? Can you give us a count on the A and B's in the chat? How many A's? How
Actually,
many B's?
I think we can see
We can see
in
we
the
can see it in the
polls.
polls. Yeah.
Yeah, it's 11 for B and 4 for A.
Okay. And if you add that to the people who are only adding into the chat, yeah, this is neck and neck, I think,
Yeah.
because a lot of
So
B's in
let's
the chat. 5 B's, Shivam says. Oh, wow. And those 5 people, or 16 people, was it? Or how many? 9 people?
something with numbers.
Yeah. All those
Math is
people are right.
mathing.
Token
Yeah.
classification. So this is what I was
Token.
talking about, that sentence earlier, like Corey presented today at Microsoft, right? The entities being the labels that we have, or the tokens. So as an entity, so Corey is a person, location, or like, let's say at Microsoft is the location, or a company. We can even do like entity recognition on companies, for example, or even grammar things, verbs, things like that you can get clear recognitions on what's in the sentences, or predictions of what's in the sentences, and then you can use those predictions for whatever your application needs for that.
I feel like someone had just had an epiphany in the chat.
Yeah, Raj is like, oh, it's because I have entities. I don't know. I'm not really sure. I don't know. Yeah, but I'm glad, Raj, that you've come to realize it's entities.
Yeah.
Perfect. Was that the last question? Oh my God,
No, we
no,
have
it's not.
two more, and then we're done. Oh, this is a mean one actually, because this is about the Azure Machine Learning Studio. So let's go to the next one.
Oh my God. Yeah, that is
Yeah.
mean. That's like a
Sorry.
direct question. Yeah.
Oh, also an interesting one. So this is also a
Let's
little bit specific for Azure Machine
Yeah,
Learning
yeah. Let's
Studio.
see. Let's just see. This is we're not going to nothing against anyone who gets this question wrong, but
Yeah.
mutual respect for anyone who has gets it right. This shows you that you've probably done some deployment or fine tuning before. So let's see. Go ahead and give us your best guess, best prediction, as you
Best
would say.
prediction.
Yeah.
And I think this also kind of relates to what we were saying earlier about Machine Learning Studio as opposed to AI Studio. So with the Machine Learning Studio, you, like I said, you use it if you really train your own models and you deploy and manage your own models. And because of that, you have a bit more opportunities to kind of customize how you do things. And you have a bit more control over the things that you use. Amongst other things, the computes that are used when you train or deploy a model. So these are all computes that are available in the Machine Learning Studio. And I think a lot of people are already guessing.
Yeah, guessing a lot of B's,
Yeah.
some A's. So no one's giving CPUs credit on being able
Yeah.
to host models, which is a shame. CPUs is where we came from, people. That's our roots.
Represent. Yeah, so here we have the answer is a GPU compute cluster. I think a lot of people had it correct. So definitely GPUs is what you want to use when it comes to deep learning models. But it's, yeah, the mean part was the instance or the cluster. And this is like a Machine Learning Studio specific thing. Instance is, I think officially maybe you could use it, but a cluster is just more cost efficient because it scales automatically for whenever you need to train or deploy. And then it also scales down automatically. So it's just, yeah, smarter to do, I would say.
Yeah, for sure.
Awesome. I think we should wrap up, right? I don't know if there's some questions that you've seen that you maybe just still want to address.
I didn't see anything. It's not because now the chat is full of A, B, C, A, B, B, C, C. I can't find anything. But yeah, thank you all for your questions. This is the Learn Live. So the whole point, right, is to learn together live. So thank you for everyone who did write in the chat. Hopefully we answered the majority of your questions. If not, feel free to add them as comments in the video. Then we'll can swing around and answer anything else that you had. And all the people who may have are going to watch this in the future and not actually seen it live. Sorry you couldn't be there with us live, but hopefully some of the questions that we've answered, you are also having those same questions. And like I said, every time I do these streams, you could have been anywhere on the internet right now, but you spent an hour and a half, not just an hour like I thought this was, but an hour and a half with us. So for that, I'm truly appreciative. Thanks, everyone. And see you tomorrow. Not me, but and Mary Jo, but other people looking at
Actually,
PromFlow and LLM.
I will be there for
Wow.
PromFlow.
Oh, yeah. Yeah,
Yeah.
Mary Jo is so in demand. She actually will be there tomorrow. So
Yeah.
there you go. I won't be
Yeah.
there, though. Well, maybe I'll be in the audience predicting wrong questions.
Yeah. Great. Yeah, so don't miss tomorrow's session. Will be great. We're going to go into PromFlow again with the Azure AI Studio. So feel free to join that session, and also you can join the Azure AI community in Discord. So here I'll leave this QR up here for people that want to join.
Yes, join the Discord. It's I'm in there all the time. It's a great community if you like asking questions and getting answers. There's plenty of Microsoft employees from MVPs as well as product people, things like that. So hopefully if you ask a question, you'll get a good answer. That's what I'll promise you.
Yeah, perfect. Well, thanks everyone, and maybe see you tomorrow.
Said confidently. Perfect.
Yeah.
Definitely see you tomorrow, everyone.
Definitely see you
Thank you.
tomorrow. Bye.